In this section, which is the last section of chapter 1, we want to talk about the other characteristic of the trigonometric functions. First thing that we want to talk is about the domain and the range of the sine and cosine function. What's the domain of the sine and cosine function? Domain means all of the possible x values. When you have a function like y equals sine x or y equals cosine x, all the values that you can replace for x create the domain. All possible values for x. And you know that x, whatever you put in front into the parenthesis in front of the sine and cosine, it's an angle. And we can have any degree angles. We can have 0 degree, we can have negative angles, we can have an angle less than 360 or even more than 360. So there is no restriction for angles that we can put for x, which means the domain of sine and cosine both is all real numbers from negative infinity to positive infinity, because we can plug in any number for x. But when we talk about the range, that means we are talking about the y values. And when I plug in an angle for x, what do I get for y? What is the value of the sine of that angle? What's the value of the cosine of that angle? The sine and cosine of any angles is coming from the unit circle. And you know that the unit circle is a circle that is centered on the origin, and the radius of the circle is 1. That means this point is 1 and this point is -1, +1 and -1. And when I talk about the y values means the sine of angle or the cosine of any angle. For example, if I have an angle here, the sine of that angle is this part. The cosine of this angle is this part. If I have an angle over here, let me just change the color. If I have another angle, the sine of angle is this part, the blue part, and the cosine is this part. And as you see, the sine and cosine are always values within -1 to +1. Within -1 to +1, the sine values. So there is no way that we get a number for a sine and cosine of an angle which is more than 1. So that's why we say the range of these functions both are from -1 to +1. If anytime in the calculation you found the sine of any angle which is, for example, 1 point something or 2 point something or -2 point something, which is not within this range, if it's degree, something is wrong. But you may have that angle in radian. We may have a sine of 1.5, we get an, but it's radian, but for the y value, we never get any number, out of this range. Next characteristic of the trigonometric functions are being an even or odd function. When we talk about the even or odd function, we say a function is even if I replace the x by -x into the function, but when I find the function, I get exactly the same as the function f of x. For example, I have a function y equal x squared. That's a function. If I replace the x by -x, and I square it because that's a part of my function, and I know the -s squared is still positive. So as you see, if I replace the x by -x, I got the same answer as I had for the function, which means this function is even. But if you replace the x by -x and your function is negative of the first function, that means your function is odd. For example, I have y equal x cubed. If I replace the x by -x, if I raise negative to the third power, I still get a negative. And that's my first function with a negative in front, which means that this function is odd. So we have this property for trigonometric function as well. But something that we know that the cosine and secant, because secant is the reciprocal of the cosine, both are even function, which means that if I have a negative number for the angle, the, the cosine of that negative angle, that's exactly the same as the cosine of the positive form of that angle, and the same for secant. But all other trigonometric functions like sine, tangent, cosecant, and cotangent are all even, odd numbers. That means if you find a sine of negative 30-degree angle, that should be the same as the negative of sine of 30 degree. But for cosine, the cosine of negative 30 degree, that's exactly the same as the cosine of 30. So for cosine and secant, since they are even, we can easily remove the negative. But for other functions, since they are odd, we have to remember that the negative stay outside. And why this happened? We can look at the unit circle again. If you look at unit circle, if, for example, that's your angle theta, and if you want to find the cosine of this angle, you just can connect it to the cosine or x-axis, and that's the cosine of angle theta. And if you have the same angle with in negative direction, like this one, which is negative theta, and if you want to find the cosine of this angle, again, you will connect it to the x-axis, and that this is the cosine of negative theta. And as you see, they are the same. The cosine of theta is exactly the same as the cosine of negative theta. But for sine, for example, if I have angle theta and I want to find the sine of this angle connected to the sine axis, and that's my sine theta. It can be 1/2, it can be root 3 over 2, it can be root 2 over 2, it can be any number between 0 and 1. But if I have a negative angle, and I want to find the sine of this angle, this is the sine of negative theta. And as you see, they are not the same because sine of theta is a positive number, sine of negative theta is a negative number. That's why the sine of negative angles are always negative of the sine of positive angles. Okay, let's look at this example. It says find the exact value of each of the trigonometric functions. The first example says find the cosine of negative 60-degree angle. So since I learned that the cosine is an even function, it means that the cosine of negative 60, that should be exactly the same as the cosine of 60. I don't care if there's negative inside the parenthesis. And I know based on the table, I know that the cosine of 60 is 1/2. So the final answer is 1/2. If I want to find the tangent of negative pi over 6, since I know the tangent is an odd function, that means I need to keep the negative outside and then find the tangent of pi over 6. And based on the table, the tangent of pi over 6 or 30-degree angle is root 3 over 3. So the answer is negative root 3 over 3. Okay, next example. I want to find the sine of negative 5 pi over 6. So first of all, I know that the sine is an odd function, which means that this negative should stay outside. And then the sine of negative 5 pi over 6, that's the same as the negative sine of 5 pi over 6. Now I only need to find the sine of 5 pi over 6. How do we find the sine of 5 pi over 6? By using the reference angle, because I don't have this angle in my table. If I want to show the angle 5 pi over 6. So pi over 6 means 30-degree angle. So that means I have 3 of them inside of each quarter. 1 pi over 6, 2 pi over 6, 3 pi, 4 pi, and 5 pi over 6. That's 5 pi over 6. And if I want to find the reference angle, I know the reference angle is an angle between the x-axis and the terminal side, which is this angle, and this angle is exactly pi over 6. So it means that the sine of 5 pi over 6, that's exactly the same as the sine of pi over 6. And since the angle in the second quadrant, the sign is positive, so it doesn't change anything for that part. But don't forget, we still have this negative, right? We need to keep that negative. Now I can check the table to find the sine of pi over 6. Pi over 6 means 30-degree angle, and the sine is 1/2. So the answer is negative 1/2. And next example, I want to find the cosine of negative 3 pi over 4. I know the cosine is an even function, which means that the negative doesn't change anything. So I can easily remove the negative, and I say that the cosine of negative 3 pi over 4, that's exactly the same as the cosine of 3 pi over 4. Now I only need to find the cosine of 3 pi over 4. How do we find it? Just again, using the reference angle. So since I have pi over 4 means 45 degree. I can just divide each quarter by 2 to get 4 parts. And 1 pi over 4, 2 pi over 4, 3 pi over 4, and that's it here. This is the angle 3 pi over 4. Now I only need to find the reference angle, which is this angle. And this angle is pi over 4. So the cosine of 3 pi over 4, that should be the same as the cosine of pi over 4. But since the 3 pi over 4 is an angle in the second quadrant, and the second quadrant, the cosine is negative, you don't forget to put the negative outside as well. Sometimes we may have a negative, like the one on part C, and after finding the reference angle, we have another negative as well. So we have to keep all the negatives and then multiply them together. And the cosine of pi over 4, which is 45 degree, is root 2 over 2. So the answer is negative root 2 over 2. Another characteristic of the sine and cosine functions, or all trigonometric functions, are being periodic functions. We call them, we say that all trigonometric functions are periodic. Periodic means they repeat, after, for all of the t in the domain of function. And based on the unit circle, that everything in the first rotation, after that, we get back, when I get to the second rotation, everything is just repeating. Means if I have an angle in the first rotation over here, and after the first rotation, if I get back to this point, my angle is different, but the answer, the sine and cosine of that angle, is exactly the same as the angle in the first rotation. So that's why we call them periodic, okay? And the period for these two functions is 2 pi. The 2 pi is the period of the function for sine and cosine, because everything after 2 pi is repeating. So you have all the values from 0 to 2 pi, but after 2 pi, everything is repeating. But for tangent and cotangent, the period of the function is pi, because tangent and cotangent, from 0 to 2 pi, everything is new, but after that, everything again is repeating. So the period for the tangent and cotangent is pi. And we use this property to find the sine and cosine, or tangent and cotangent, of some angles that are in other rotations, the rotation more than first rotation, like second rotation, third rotation, all the angles that are more than 360 degrees. For example, if I want to find the cosine of 405 degree, I know that the 405 is more than 360, which means that it's in the second rotation. So since it's in the second rotation, I can easily remove the first rotation, because when I go back, after the one rotation, when you start from the first quadrant again, everything should be the same as the first rotation. So it doesn't matter that we already had one rotation. We can easily remove that part. So if I have 405, I can subtract 360 from 405, and then I get 45 degrees. And I can say the cosine of 405, that's exactly the same as the cosine of 45 degrees. Because if 45 degree angle is this angle in the first rotation, 405 is this angle. But the sine and cosine is exactly the same. It doesn't matter we have 405 degree or we have 45 degree, because they are in the same location on the coordinate plane. And I know that the cosine of 45 degree is root 2 over 2, which means that the cosine of 405 degree is also root 2 over 2. So anytime you have a 360 degree plus something, you can remove that 360 part. For next one, we want to find the sine of 7 pi over 3. Okay, 7 pi over 3. When you have pi over 3, you know that the 2 pi is 6 pi over 3. When you want to find the sine of 7 pi over 3, which means your angle is after the first rotation, because the first rotation is all the way to the 6 pi over 3. And you want to find an angle which is greater than 2 pi. So that's why we can subtract the 2 pi from that angle. And if I subtract 2 pi from 7 pi over 3, I end up to pi over 3, which means 7 pi over 3, that's exactly the same as the 2 pi plus pi over 3. And I can show on the coordinate plane as well. So that's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi, and 6 pi over 3, and 7 pi over 3. Get back to this one. That's why we say the sine of 7 pi over 3, that's exactly the same as the sine of pi over 3, and the sine of pi over 3 is root 3 over 2. That's why I told you, if you know this 30 degree, 45 degree, and 60 degree, you can find the trigonometric function for a lot of angles after that. To find the cosine of 810 degree, again, 810, we need to see how many rotation do we have before getting to 810. So you know that the first rotation is 360 degree. If I have another rotation or adding another 360, I will have 720. But still my angle is greater than 720, which means this angle is in the third rotation, because the first rotation is from 0 to 360. Second rotation is from 360 to 720. Now we have 810, which is 810 is 90 degree more than 720. So instead of 810, you can say 90 degree plus 360 plus another 360. And you can easily remove the 360s. And you say that the cosine of 810, that's exactly the same as the cosine of 90 degree. And I know that the cosine of 90 degree is 0. Next example, ask us to find the sine of 11 pi over 4. Since the denominator is 4, I know that the 2 pi is exactly 8 pi over 4, because 8 divided by 4 is 2. But your angle is 11 pi over 4, which means it's more than 2 pi. So if you want to show on the coordinate plane, 11 pi over 4 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 4. It's over here. Which means it's 3 pi over 4 more than 2 pi. Okay, I can remove 2 pi. So I resolve that the sine of 11 pi over 4 must be the same as the sine of 3 pi over 4. Now the question is, okay, still 3 pi over 4 is not on my table. How can I find the sine of 3 pi over 4? Using the reference angle. 3 pi over 4 is over here. And the reference angle is this angle, which is pi over 4. So this one is also the same as the sine of pi over 4. And since it's in the second quadrant, sine is positive, so I keep it positive. And the sine of pi over 4, that is a root 2 over 2. So you can say the sine of 11 pi over 4, that's exactly the same as the sine of 3 pi over 4, and that's exactly the same as the sine of pi over 4, and the answer is root 2 over 2. This is how we use periodic properties of these functions to remove each rotation. Next example, it says use reference angle to find the exact value of cosine of 150 and sine of 150. Okay, so easy. We need to show 150. 150 is in the second quadrant, because we know that in the first quadrant, all angles are from 0 to 90. 90 to 180 are on the second quadrant. 180 to 270 are on the third quadrant, and 270 to 360 are on the fourth quadrant. My angle is 150, which means it's in the second quadrant. Okay. What's the reference angle for this angle? The reference angle is this angle, which is 30-degree angle. So I can say that the cosine of 150 degree is the same as the cosine of 30 degree. And the sine of 150 degree, that's the same as the sine of 30 degree. But we need to also pay attention to the quadrant that the angle is. 150-degree angle is in the second quadrant. In the second quadrant, the sine is positive. That's a y-axis. So I keep the sine positive. But the cosine is negative. So I have to put a negative for the cosine. Now I can look at the table and find the sine and cosine of 30-degree angle. And I know that the cosine of 30 is root 3 over 2. And the sine of 30 is 1/2. And these are the answers for the sine and cosine of 150-degree angle. To find the sine and cosine of 5 pi over 4, I need to show 5 pi over 4 in the coordinate plane first. So we have pi over 4, that means divide each quarter by 2. I have 1 pi over 4, 2, 3, 4, and 5. Okay, that's 5 pi over 4 angle in the third quadrant. So if I want to find the reference angle is this angle, which is pi over 4. Yeah. So the sine of 5 pi over 4, that's the same as the sine of pi over 4. The cosine of 5 pi over 4 is also the same as the cosine of pi over 4. But since the angle is in the third quadrant, in third quadrant, sine and cosine both are negative. And the sine of pi over 4 is root 2 over 2 with a negative. Cosine is also root 2 over 2. And these are the answers for sine and cosine of 5 pi over 4. And this picture is a full um, unicircle with all of the possible angles that we may have. And you know, these are the coordinates of the point. For example, these are the coordinates of this point. And also they are the sine and cosine of 30-degree angle, or pi over 6. Because you know that the x is always the cosine and the y is always the sine. So you can have a print of this paper, a copy of this paper with yourself anytime you are working on the problem that you looking at this table to find answers, or you can also find it just by knowing 30, 45, and 60 degree. You can find other angles just manually based on what we learned so far. Next example, it says find the coordinates of the point on the unicircle at an angle of 7 pi over 6. I can go back and to this picture and find the coordinate for that angle, but I want to do it by myself. I don't want to look at that table. And see how we can find the coordinates of 7 pi over 6. Let's find 7 pi over 6 on the unicircle. Pi over 6 means 30 degrees, and each quarter can be divided to 3 30-degree angles. So we have 3 of them in each quarter. I need 7 of these 30 degrees. So 1, 2, 3, 4, 5, 6, 7. Okay, that's the 7 pi over 6. When it tells me to find the coordinate, that means find the x and y of this point. But you know that the x and y of this point means the cosine and sine of this angle, 7 pi over 6. So if you can find the sine and cosine of 7 pi over 6, that means you have the coordinate of the point. How we can find the sine and cosine of 7 pi over 6? By just finding the reference angle. The reference angle in this example is pi over 6. So you say that the sine of 7 pi over 6, that's the same as the sine of pi over 6, but since it's in the third quadrant, the sign is negative. So the answer is negative 1/2. The cosine of 7 pi over 6, that's exactly the same as the cosine of pi over 6. Again, we are in the third quadrant. The cosine is also negative. So the answer is negative root 3 over. Now, if you are writing the coordinates of the point, instead of x and y, we put cosine and sine. X is the cosine, which is negative root 3 over 2. Y is the sine, which is negative 1/2. And these are the coordinates of that point on the unicircle for angle 7 pi over 6. Okay, next example it says, if cosine of an angle t is 12 over 13 and t is an angle in the quadrant 4, find the sine of angle t. Okay, we know that t is an angle in the fourth quadrant. And in the fourth quadrant, how does it help me? It tells me that the cosine is positive, but the sine is negative. So you just have to remember this, because when you find the sine, you need to make sure that your sine is a negative number. Now, how we can find it? There are different ways to find the sine. So I want to show you. I can use the right triangle properties for x, y, and r, and use those formula. And I can say that when it says the cosine is 12 over 13, I know that the cosine is always x over r, which means the x must be 12, r must be 13. And if I want to find the sine of t, That means I want to find, I need to have y over r. I know the r, but I need to find the y. How we can find the y? By using the Pythagorean theorem, which is r squared is equal to x squared plus y squared, which means 13 squared is equal to 12 squared plus y squared. 169 is equal to 144 plus y squared. Isolate the y. So you have y squared, which is 169 minus 144, and it's 25. And if I take the square root, I get that the y must be equal to 5. But whenever I take the square root from the both sides, I have two options, positive and negative. Which one works here? Since the angle is in quadrant 4 and y must be negative in quadrant 4, I only keep the negative. So I say the y is negative 5, so which means the sine is negative 5 over 13. That's it. Do we have any other way to find this one? Yes, we can also use the trigonometric identities. If you remember in previous section, we talked about some of the trigonometric identities. And one of the famous trigonometric identities is this one, which is the sine square plus cosine square is always equal to 1. Whenever one of the sine and cosine is given to you and the other one is asking to find, you will use this one. Right now, I want to find sine, so I subtract the cosine square from the both sides first because I want to isolate the sine. And I can say the sine square of t is equal to 1 minus cosine square of t. Cosine is given to me. I can replace it with that number. So I can replace the cosine with 12 over 13. But don't forget there is a square on top of that. We raise 12 over 13 to the second power. Then we find the common denominator between these two, which is 169. So sine squared is 25 over 169. I want to find the sine, which means I need to take the square root from the both sides. And the sine t must be equal to 5 over 13. Again, when we take the square root from the both sides, we need to know if it's a positive or negative or both. In this case, since the t is in the quadrant 4, we only have to accept the negative sign, which is negative 5 over 13. And you see we get the same answer, but there are different ways you can use Greek identities, you can use right triangle properties, anyone that is you feel more comfortable with, you can use that one.